In this video you will learn how to calculate the number of electrons that flow through a conductor in a specific time, for example 1 second, at a given current, let's say 2 amps or 4 amps or 10 amps. You will learn how to calculate the total transported charge in the first step, and then how to determine in the second step how many individual charge carriers there are using the concept of elementary charge. We will also run a numerical example which has you calculate how many electrons are typically moved during the charging process of a smartphone. My name is Andreas from The Fearless Engineer, and here we go. Now, before we dive into this practical example here, let's briefly talk about the motivation, why it makes sense to conduct this exercise here. Now, the movement of charges in a field, in an electric field, this is one of the most important mechanisms which we have for energy transportation in electrical engineering and electronics. And if we want to transport energy into a circuit, this is the way to go. And in this task, we will calculate the number of electrons that are transported as a function of current, amperage, and also time. So we get to the heart of the matter, we get to the heart of energy transportation. This is why it's interesting to conduct this exercise. And our approach consists of 3 major steps here. In the first, we want to determine the transported electrical charge. Then we want to determine the elementary charge number, the number of elementary charges that are transported. So first the total amount of charges, then the number of elementary charges, and based on these 2 parameters we can simply deduce the number of charges transported per time. And then in the third step we want to use these equations which we derived in steps 1 and 2 to run a numerical example. So let's start. Now in the first step, let's determine the transported electrical charge, the total amount of charges that's transported through a conductor. And in order to do so, we can use this equation which we have seen before, the equation of electrical current, which is simply the ratio between charge Q and time t. And we can simply reshape this equation to hold the charge on the left side, and this is simply then the product between current and time. So charge is the product between current and time, amperage and seconds. So now that we have a definition for the amount of charge passing through a wire, which is the product between a current and a time t, over which we observe the current flow, we want to go 1 step further now, and we want to compute the number of electrons that are moving through the conductor given a certain current, given a certain amount of time. And in order to get to this relationship between number of electrons and current and time on the other side, we need to exploit the fact that the smallest amount of charge which we find in nature is the elementary charge. It's this very small number here, 1.602 times 10 to the minus 19 coulomb. We have talked about elementary charge before, and the idea which we employ here now is that we can get the number of electrons, because this also is the charge of 1 electron. The elementary charge is the charge of 1 electron. And if we divide the total amount of charge Q by this elementary charge, we get the number of electrons which are moving through the conductor. And by using the definition from the previous slide, replace Q with the product of I and T, we can get to this very simple relationship here, or the simple form. The number of electrons is the product between current flow times time t, over which we observe it, divided by the elementary charge E minus. And another way to express the amount of charge Q, we have used coulomb up until now, we can also express it as the product between amps and time. Ampere second is the base unit out of which the charge is composed. And this can be seen here on the right hand side, which is the product between current and time. So it fits together very nicely here. Now let's run an actual numerical example here. What we want to do now is we want to calculate in the example how many electrons flow through a conductor per second at a current of, in the example, 2.1 amps, which is the maximum charging current which I got from the manual of my Apple power supply. And if we take this amount of current here, 2.1 amps, insert it into the equation and multiply it with 1 second, which is the time over which we observe this, and divide it by the divided by the elementary charge, 1.602 times 10 to the minus 19 amp seconds, then we get this huge staggering number here, 1.31 times 10 to the 19, which is 13.1 billion electrons. So this number here is the large number of elementary charges that are provided by the Apple power supply over the time span of 1 second if it provides the smartphone it is loading with this current here of 2.1 amps. So this is a huge amount, and it gives you a good impression of the amount of energy that's actually transported by this large quantity of electrons moving a conductor. That's basically all there is to this rather simple example here. I hope you enjoyed it, and if you have any questions, please don't hesitate to drop me a comment down below. I wish you a nice day and see you next time here on The Fearless Engineer.